Welcome to the Forge Over 40 podcast. My name is Steve Didier, and this show is for high performers who refuse to let their edge quietly erode. If you've built companies, led teams, carried responsibility for decades, but lately your focus feels duller, decisions feel heavier, and your mental stamina isn't quite what it used to be, this is where we rebuild the biological systems that your leadership depends on. And we do it on a physiological level. So let me start with a pattern that I see all the time in high performers over 40. You used to attack your work. You'd walk into the office or open the laptop and your brain would lock into problems immediately. Decisions were fast, energy was steady, your drive felt automatic. You didn't have to manufacture motivation, it was just there all the time. Now, something feels different. You're still disciplined, you still show up, you still do the work, but everything feels a bit sluggish. The same workload drains more energy than it used to. The same problems require more mental effort, and the same long days leave you just a bit more depleted. And if you're honest with yourself, the internal drive that used to power everything you do feels like it's faded a little. Not gone, just different, a little quieter. And this is the moment when a lot of high performers start second guessing themselves. They wonder if something psychological has changed. Maybe they're losing their edge. Maybe they're getting burned out. Or maybe they just need a vacation. Or worse, they start hearing advice that completely misses the real problem. Things like, you just need more motivation. Or maybe you need to reconnect with your purpose. Or maybe you're just not passionate about the work anymore. Let me say something very clearly. If you built a career through discipline, responsibility, and sustained effort, your drive didn't suddenly disappear because you lost your passion. Drive is not a personality trait that randomly fades. It is heavily influenced by biology, and when biological systems that support energy, focus, and resilience start drifting, the experience of drive changes with it. Because motivation is not just psychological, it's biochemical. Your brain runs on energy. Specifically, it runs on ATP produced by your mitochondria. That energy fuels neurotransmitters that control focus, motivation, and reward signaling. When those systems are functioning well, effort feels engaging, challenges feel stimulating, work feels meaningful. But when those systems start running under chronic stress, metabolic instability, and sleep disruption, the brain's energy supply becomes much less reliable. And when the brain starts running on less fuel, the experience of drive changes. Everything feels a little harder. And it's not because you're weak, but it's because the biological engine that supports your performance is running under strain. Now, here's the part that many people never hear. Burnout is not primarily a motivation problem. It is a physiological problem. And the reason that this matters is because the solutions most people are given are completely backwards. When somebody starts feeling burned out, the advice usually sounds like this. Go ahead and take some time off. Read a motivational book. Reframe your mindset, or try a different productivity system. The problem is none of these things address the biological systems that are actually responsible for sustained performance. Let me give you a quick example from my own life. During the years I was running a real estate business while training for Muay Thai fights, the workload was intense. Business all day, then sparring, strength and conditioning work, pad work, road work. From the outside, it looked like discipline. And it was. It required an enormous amount of discipline. But what was happening physiologically was something very different. I was stacking enormous stress on my system. Physical stress, mental stress, sleep disruption, caffeine, pre-workout, constant activation of the nervous system. And eventually, something specific started happening. The drive to push forward was still there mentally, but the system underneath it was getting worn down. Focus required a lot more effort. Recovery started taking longer. Energy became much less stable. And I remember realizing something that a lot of high performers eventually discover. You cannot willpower your way past a biological deficit forever. Eventually, the physiology is going to push back. And that's exactly what burnout looks like in many driven individuals. The drive itself hasn't disappeared, but the infrastructure supporting that drive has eroded. And the worst part is that many high performers respond to the situation in the only way they know how. They push harder, more work, more caffeine, harder training, more pressure. But pushing harder on a system that's already strained doesn't restore drive. It accelerates the breakdown because the systems that support sustained performance operate in a hierarchy. At the very top of that hierarchy is mitochondrial energy production. Directly below that is metabolic stability, then nervous system regulation, then hormonal signaling, and finally, the experience that we call motivation. If the upstream systems are unstable, motivation becomes unreliable no matter how disciplined that person is, which is why so many high performers over 40 experience the exact same confusing pattern. They still care very deeply about their work. They still want to perform, but the internal engine that used to power that drive just feels weaker. The good news is that this process is not mysterious and it's not permanent. Once you understand the biological systems that support sustained performance, you can rebuild them, you can recalibrate them. And when those systems come back online, something kind of neat happens. Drive returns with them. Now, we're going to talk about the biological systems that actually control motivation and drive, because once you understand how energy production, neurotransmitters, and nervous system signaling interact, the burnout pattern that many high performers experience after 40 starts making a lot more sense. So let's talk briefly about something most people misunderstand about motivation. People tend to think motivation is purely psychological. They assume it's about discipline or mindset or mental toughness. But motivation is actually rooted in neurobiology. Specifically, it's strongly tied to a neurotransmitter called dopamine. Dopamine is the brain's motivation signal. It's the chemical that makes effort feel rewarding. It's what drives curiosity, ambition, and the willingness to engage with difficult challenging. When dopamine signaling is strong, work feels engaging. Problems feel interesting to solve. Long days feel stimulating rather than draining. But dopamine production and dopamine signaling are heavily dependent on the energy availability inside the brain. Your brain is an energy-intensive organ. It runs on a constant supply of ATP produced by the mitochondria. When mitochondrial output is strong, the brain has the resources it needs to maintain healthy neurotransmitter signaling. Dopamine functions properly. Focus remains stable. Drive feels natural. But when mitochondrial energy production declines, even slightly, the brain starts prioritizing basic function over optimization. One of the first systems that gets affected is dopamine signaling. This is where burnout begins changing how work feels. Tasks that used to feel stimulating now feel heavier. Projects that once sparked excitement now feel like obligations. The drive to initiate effort weakens, and not because the person has lost their ambition, but because the biological systems that support motivation are running under an energy deficit. So now, layer chronic stress on top of that. Remember what we talked about in earlier episodes. High performers tend to run their nervous systems in sympathetic activation for long periods of time. Constant problem solving, constant responsibility, constant decision making. Over time, that chronic stress environment begins altering neurotransmitter balance. Cortisol remains elevated much longer than it should. Inflammation starts to creep upward. Sleep depth becomes lighter. And all of those things influence dopamine signaling in the brain. The result is subtle but powerful. Motivation becomes harder to access, and effort feels more draining. The brain becomes more resistant to initiating work that used to feel natural. Now, here's the part that many people don't recognize. The modern world makes the situation much worse. Because we're surrounded by artificial dopamine stimulation, social media, constant notification, news cycles, and short bursts of novelty throughout the day, each of these things produces small dopamine spikes. Individually, they seem harmless, but collectively, they create a pattern where the brain becomes accustomed to frequent, low-effort dopamine hits. That changes how the brain responds to more demanding work. Things like long-term projects, strategic thinking, deep concentration. These things require sustained effort before the reward arrives. If the brain has been conditioned to expect quick dopamine hits from screens and digital stimulation, it becomes less willing to invest energy in slower, more demanding work. This is one of the hidden drivers of burnout in modern professionals. The brain becomes both underfueled and overstimulated at the same time. Energy availability declines, but stimulation increases. That combination creates a nervous system that feels restless, yet fatigued. You can scroll endlessly, but initiating deep work takes a lot more effort. You can respond to emails, but tackling a complex project feels much heavier. This isn't a personality flaw. It's a biological environment that has become misaligned with the kind of work that high performers need to do. Now, if we add sleep disruption into the mix, sleep is one of the most primary times when the brain restores neurotransmitter balance. During deep sleep, the brain clears metabolic waste. Neurotransmitter systems reset and hormone rhythms rebalance. If sleep becomes shallow or fragmented, the brain starts the next day with reduced recovery. Over time, that deficit accumulates. Dopamine signaling weakens, mental endurance declines, and motivation becomes much harder to sustain, which leads many high performers to compensate with the only tools they know how. More caffeine, more pressure, more forcing. But forcing motivation on a system that's biologically depleted rarely works in the long term. You very well might push through temporarily, but essentially your system is going to push back. Your energy is going to crash. Drive is going to weaken. Burnout is going to deepen. And the person experiencing it begins questioning themselves. They start wondering whether they've maybe lost something internally. But in reality, what they're experiencing is the predictable outcome of a biological system that has been running under chronic load without enough recovery. The encouraging part is that the brain is incredibly adaptable. When the underlying physiology improves, dopamine signaling improves with it. Energy stabilizes, sleep deepens, metabolic stability returns, and the experience of drive begins returning as well. This is why the conversation around burnout needs to move away from psychology alone. Mindset obviously matters, discipline matters, but the biological systems that power motivation matter just as much or more, in my opinion. In the final part of this podcast, we're going to talk about high performers rebuild those systems so that motivation and drive stop feeling like something they have to force. Because once the underlying physiology improves, something specific happens. Work stops feeling like a grind, and the drive that built your success begins showing up again naturally. So now we are getting to the crux of this whole conversation. If burnout is rooted in biology, how do you rebuild the systems that support your drive? Because the solution, obviously, isn't more pressure. It's not another productivity hack, and it's not trying to shame yourself back into motivation. The real solution is restoring the biological foundation of sustained performance. When that foundation stabilizes, drive stops feeling forced. It starts showing up naturally again. And the first place to start is energy production. Your brain's ability to generate motivation is heavily dependent on mitochondrial output. If your cells aren't producing energy efficiently, the brain will prioritize basic survival processes over high-level engagement. This is why the first step in restoring drive is rebuilding the conditions that allow mitochondria to function well. Consistent movement, strength training that maintains muscle mass, aerobic work that improves oxygen delivery and mitochondrial density. Muscle tissue itself plays a massive role in metabolic stability. It improves glucose regulation, it increases insulin sensitivity, and it provides the metabolic flexibility your body needs to maintain energy under stress. As we move past 40, protecting muscle becomes one of the most important biological investments you can make, if not the most important, because muscle supports the entire metabolic system. Now, the second piece is metabolic stability. Your brain needs a predictable supply of fuel. When blood sugar swings wildly throughout the day, the nervous system constantly has to compensate. Stress hormones get involved. Cortisol rises, adrenaline pulses. Those signals can temporarily restore alertness, but they also keep the nervous system locked into stress mode. Stable fueling patterns help smooth that entire system out, providing protein early in the day, avoiding the pattern where caffeine becomes a primary fuel source for the first half of the day, balancing your meals so the brain receives consistent energy instead of roller coaster spikes and crashes. When metabolic signals become stable, the nervous system becomes calmer. And when the nervous system becomes calmer, the brain can allocate more resources toward motivation and cognitive endurance. So now let's touch on something that a lot of high performers underestimate: recovery windows. Driven individuals are incredibly good at applying stress. They train hard, they work long hours, they push through challenges. All of that stress can be very productive, but adaptation only happens during recovery. If the nervous system never receives clear signals that the stress phase is over, the system never fully repairs itself, which is why strategic recovery matters so much. That doesn't mean doing nothing. It means deliberately creating moments where the nervous system shifts out of constant activation. Walking outside after dinner, lower lighting in the evening, reducing screen stimulation later in the evening. Seriously, just put down the phone. It'll do wonders for you. These things may seem simple, but they are powerful signals to the brain. They tell the system that the threat phase has ended. And when that signal repeats consistently, your sleep quality improves. Now, sleep itself deserves its own spotlight here, because sleep is when the biological repair processes actually happen. During deep sleep, several critical things occur. The brain clears metabolic waste. Neurotransmitters are reset, hormone rhythms rebalance, growth hormone pulses to repair tissue, testosterone production occurs in men. And if sleep becomes shallow or fragmented, the entire recovery process weakens, which means the next day begins with less biological capacity than the one before it. Over time, that deficit accumulates. Energy drops, drive weakens, and focus becomes much harder to maintain. And this is another reason I want to kind of mention alcohol as well. High performers use alcohol many times as their decompression tool. A couple drinks toward the end of the day feels like a reward. It's a signal the workday is over. But physiologically, alcohol interferes with the exact sleep cycles the brain needs for recovery. It fragments REM sleep, it reduces deep sleep, and it increases nighttime awakenings even if you don't remember them. The result is sleep that appears long enough but never fully restores the system. Reducing alcohol frequency, even modestly, often produces dramatic improvements in sleep depth and next day energy. When sleep improves, everything downstream improves with it. Hormone signaling stabilizes, metabolic efficiency increases, neurotransmitter balance improves, and motivation becomes much easier to access again. Now, this entire process is exactly why the framework that I use with clients, the assess method, starts upstream. Before we start obsessing over hormone numbers and before we chase complicated optimization protocols, we evaluate the systems that control the entire hierarchy, starting with mitochondrial energy production, moving to metabolic stability, then to nervous system regulation, circadian rhythm. And once those systems stabilize, something interesting happens. The experience of burnout begins fading. Energy becomes reliable again, focus sharpens, recovery accelerates, and that drive that once felt buried begins showing up again naturally. Because the truth is this: most high performers don't lose their ambition. They simply lose the biological capacity that supported their ambition. And when that capacity is rebuilt, the engine that powered your success begins running smoothly again. If you want to start rebuilding that foundation, my 30-day program, the Energy Reset Blueprint, walks through the exact sequence for restoring energy production, metabolic stability, and nervous system resilience. It's free, and the link is in the description. Grab it. And keep this last thing in mind. You don't tolerate mediocrity in your business. Don't tolerate it in your biology. I'll see you all again very soon. Take care.